And happy Tuesday morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at email@ybcc.edu and I'll respond as soon as I can. All right, so we have a request. We're going to do, this is, let's see, what is this here? This is section 10.2, part 1, number 21. It says, use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. And the equation is the following. X squared over 12 minus x over 6 equals 1/2. So the first thing I'm going to do is put it in standard form. I'm going to subtract 1/2 from both sides of the equation. That will give me x squared over 12 minus x over 6 minus 1/2 equals 0. The next thing I'm going to do is clear the fractions. I'll multiply both sides by the LCD, which is 12. So 12 times x squared over 12 would be x squared minus 12 times x over 6. The 12 over 6 reduces to 2 over 1, so minus 2x. And then minus 12 times 1/2. 12 over 2 is 6 over 1 minus 6 equals 0 times 12 is 0. Okay, so now I've got it in standard form and I've cleared the fractions. A is 1, B is -2, and C is -6. So plugging those values into the quadratic formula, x equals -b plus or minus the square root of b, the quantity squared, minus 4ac all over 2a. X equals 2 plus or minus the square root of 4 plus 24 all over 2. Good morning, Russ. X equals 2 plus or minus the square root of 28 all over 2. X equals 2. Oh, hang on. We can take the square root of 28, which is the square root of 4 times 7, which is 2 square roots of 7, and rewrite the expression x equals 2 plus or minus 2 square roots of 7 over 2. We can then split it up and write 2 over 2 plus or minus 2 square roots of 7 over 2. X is 1 plus or minus the square root of 7. So we get x equals 1 plus the square root of 7, 1 minus the square root of 7 as our two answers. Any questions about that before we go on? Okay. All right. Got a bloody nose this morning? Bummer. Okay. Now we're going to go on to finish up section 10.2. And I've got a drawing here of a situation. It says, refer to the illustration. Instead of using the Main Street and First Street crosswalks to get from Nordstrom's to Best Buy, a shopper uses the Diagonal Crosswalk. Okay, so basically, instead of doing this and then that, they're going to do this. Okay. Let's see. It says, shopper uses a diagonal crosswalk to walk 97 feet directly from one corner to the other. So what we have here is a right triangle. And this distance is 97 feet. It says, if the length of the Main Street crosswalk, which is this one, is 7 feet longer than the First Avenue crosswalk, which is that one. So the Main Street crosswalk is 7 feet longer than the First Avenue crosswalk. Let's call the First Avenue crosswalk X. The Main Street one would be X plus 7. So basically what we've got now is a right triangle with the sides labeled, the longest side 97 feet, the other two sides X and X plus 7. There is a formula called the Pythagorean Theorem that says a squared plus b squared equals, let's put that a little closer, a squared plus b squared equals c squared. And what you have is you have a right triangle, okay? The longest side, also known as the hypotenuse, is always c. The other two sides, which are known as the legs, are labeled a and b. Since addition is commutative, it doesn't really matter which leg is a and which leg is b. But we're going to use this Pythagorean theorem to come up with the value of x and x plus 7 in our example. All right. Any questions before we proceed? Okay. So what I'm going to do is I'm going to go to the next page and just draw the right triangle. This is 97, this is x, and this is x plus 7. I'm going to label these a, b, and c. And again, a squared plus b squared equals c squared. So that means the following: x plus 7 squared plus x squared equals 97 squared. X plus 7 squared would be x plus 7 times x plus 7. X squared would be x squared. And 97 squared, let's see here, 97 squared is 9,409. So foiling together the x squared, or the x plus 7 times x plus 7, we get x squared plus 7x plus 7x plus 49 plus x squared equals 9,409. Combining like terms, we get 2x squared plus 14x plus 49 equals 9,409. Putting this in standard form, we'll subtract 9,409 from both sides, and we get 2x squared plus 14x minus 9,360. I think that's correct. Let me check my math here. 49 minus 9,409. Yes, 9,360. Okay, I can reduce this down by dividing everything by 2. So I get x squared plus 7x minus, let's see here, 9,360 divided by 2 is 4,680 equals 0. I'm going to use the quadratic formula to solve this. A is 1, B is 7, C is negative 4,680. See if we can fit this all in here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 7 plus or minus the square root of 49. And then we've got minus 4 times 1, which is negative 4, times negative 4,680, which is positive 18,720 all over 2. X equals negative 7 plus or minus the square root of, let's see, 18,720 plus 49 is 18,769 all over 2. Let's see if 18,769 is a perfect square. It is. It's the square root of it is 137. Okay. So now we've got x equals negative 7 plus 137 over 2 which is 130 over 2, which is 65. And we've got x equals -7 minus 137 over 2, which is -144 over 2, which is -72. So we've got x equals 65 and x equals -72. Now, the problem is x represents a distance across a crosswalk. We can't have a negative distance. So even though -72 is a solution to this equation, it's not a solution to the actual problem. So x is 65, x plus 7 would be what? 65 plus 72. These are all feet. But the question said, how much walking does the shopper save by using the diagonal? All right, so if we take, let's go to the next page. 72 plus 65 is 137. And then we subtract the 97, we get what? 40 feet. So the person saves 40 feet by taking the diagonal instead of these two sides. Any questions about that? And I know you're sitting there thinking, you know, all that time just to save 40 feet, it would have just been quicker to walk the extra feet. I know. All right. So we're going to take a look at another problem. This says right triangles. Okay. The Pythagorean theorem only works with right triangles. So we have a right triangle. The hypotenuse of a right triangle is 2.5 units long. Again, that's always the longest side, the side across from the right angle. The longer leg is 1.7 units longer than the shorter leg. Well, this looks to be the shorter leg, so this would be x plus 1.7 units. Okay, so basically, another example of what we just looked at, only we're not starting with as much as sidewalks, it's just a triangle. So this is A and B and C. So using a squared plus b squared equals c squared, we get the following. X squared plus x plus 1.7 squared equals 2.5 squared. X squared is just that, x squared. X plus 1.7, the quantity squared, is x plus 1.7 times x plus 1.7, and 2.5, the quantity squared, is 6.25. Foiling, I get x squared plus x squared plus 1.7x plus 1.7x plus, I believe it's 2.89. Let me confirm that. I think that 1.7 times 1.7, yeah, 2.89. Don't be impressed. I've done this problem 100 times. Okay. So then this becomes, oh, this is equal to 6.25. Combining like terms, 2x squared plus 3.4x plus 2.89 equals 6.25. We'll subtract 6.25 from both sides. 2x squared plus 3.4x minus, let's see here, if I take 2.89 minus 6.25, I get minus 3.36 equals 0. Well, I don't want to have to deal with the decimals, so I'm going to multiply both sides by 100. So that gives me 200x squared plus, let's see here, 340x minus 336 equals 0. And now I could reduce it down. I could take a 4 out of everything. And again, you don't have to. It just makes the numbers nicer to work with. 50x squared plus, let's see, 340 divided by 4 is 85x. And then 336 divided by 4 is 84 equals 0. Okay, so all that is to get a quadratic equation in standard form, and it's no decimals, no fractions, reduced down. I'm going to take that and go to the next page. Let's see, 50, 85, 84. 50, x squared plus 85x minus 84 equals 0. All right. So A is 50, B is 85, C is negative 84, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 85 plus or minus the square root of 85 squared is 7,225. And then we've got minus 4 times 50, which is minus 200 or negative 200 times negative 84. And I get positive 16,800 all over 2 times 50 or 100. 16,800 plus 7,225 is 24,025 over 100. And the square root of that is 155, the square root of 24,025. So we've got that lovely thing. So let's see here. What do we got? We've got x equals negative 85 plus 155 over 100, which would be, let's see, 155 minus 85 would be 70 over 100 or 0.7. Now, I could write 7/10. The reason I'm writing 0.7 is just because our original problem, that's a 7. Our original problem was in decimal form. And then we've got x equals negative 85 minus 155 over 100. And let's see there, we've got negative 85 minus 155 is negative 240 over 100, which would be negative 2.4. So x is 0.7, x is negative 2.4. However, just like the last example, x is a distance. So x can't be negative. Now, that doesn't mean that every time we solve the quadratic formula and we get 2 answers, we throw out a negative answer. This is an application applied to a distance, so it can't be negative. So it's got to be, this is what, 0.7. This is what, 0.7 plus 1.7 is 2.4. And it just said units. So one leg is 0.7 units. Other leg is 2.4 units. All righty. Any questions about that one?
Is there not a quicker way to solve these problems?
Such as?
I don't know. So whenever like the question popped up, my first inkling was I bet that's about 0.7. So is there some way to figure them out quicker? Because I mean, if you take C and you just look at C, you can kind of get a gist for what the answer is going to be around. So is there a way to figure out without going through the whole process?
Well, and again, this is used in construction. I don't know if you've ever worked in construction, but the whole right triangle thing. And I don't think I'd want to be in a building where it was based on around.
Roger that.
So it's like, yeah, you could probably guesstimate it. And there are some very common, like a 3, 4, 5 right triangle. Because 3 squared plus 4 squared equals 5 squared, 9 plus 16 equals 25, 25 equals 25. So there are some common, what are known as Pythagorean triples, 3, 4, 5. But if it's not something that's a common one, it would be hard to get it exact. You know, I mean, sure, you could plug it into a computer and get an answer instantly, I'm sure, but no doing that on the test now. Anyway, but yeah, I'm not aware of a process that's faster. If I did, I'd tell you. But yeah, I know it seems like an awful lot of work, doesn't it? If it was easy, everybody'd be doing it instead of just you and me.
Right.
All right, we're going to take a look now at a rectangle. It says the largest permanent movie screen is in the Panasonic IMAX Theater at Darling Harbour, Sydney, Australia. Now, this book is old, so that may not be the largest one, but it says the rectangular screen, okay, so now we're dealing with a rectangle, has an area of 11,349 square feet. So the area is 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. Let's call this the length and this the width. It says it's 20 feet longer than it is wide. So the length is being compared to the width. We'll call the width X, the length will be X plus 20 feet. Okay with the setup? So using the formula area equals length times width, we've got 11,349 equals X plus 20 times X. 11,349 equals X squared plus 20X. Subtract 11,349 from both sides of the equation, and we get 0 equals X squared plus 20X minus 11,349. So now we're going to use the quadratic formula to solve that. And we've got A is 1, B is 20, C is negative 11,349, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A, X equals negative 20 plus or minus the square root of 400. And then we take negative 4 times 1 is still negative 4, and then negative 4 times negative 11,349 would be 45,396, all of that over 2. So then we get X is negative 20 plus or minus the square root of 45,396 plus 400 is 45,796 all over 2. Let's see if 45,796 is a perfect square. We'll take the square root of that, and it's 214. Nice. All over 2. So now I've got X is negative 20 plus 214 over 2, which is what? 194 over 2, which would be 97. I think that's right. And then let's see, we've got X is negative 20 minus 214 over 2, which is negative 234 over 2, which is negative 167. Oops, negative 167. So again, we're dealing with a distance, so it can't be negative. So this is 97 feet, and this is 117 feet. So the width, 97 feet, the length, 117 feet. Okay. Now, if you were allowed to use a graphing calculator, you could punch this into a graphing calculator, find your x-intercepts, and you could solve it. So in other words, there's a quick way to do this, but it's still based on this same mathematics. It's doing it electronically, but yeah. So I suppose if you were out in the field actually doing this, but we got to teach you the alphabet so that you can use the, use the book, so to speak. All right. Let's see here. Okay. Another fun drawing. Bear with me for a minute here while I attempt to draw. Let's see, we've got this. That. Okay. And let's see what else. We know that from here to here is 5 inches. And from here to here is 4 inches. And we have a lovely painting inside here with some trees and some water and a sailboat. Again, you can see why I'm not teaching art classes this quarter. Okay, so we've got this picture. It's a picture of a sailboat on a lake up in the mountains. There's a mat. The frame is a mat, and it says the matting around the picture has a uniform width. So this distance right here is the same as this distance, as the same as this distance, as the same as this distance. And we're going to call that X, okay? So the uniform width around it is, the width is X. We don't know what that is. That's what they're going to want us to find. It says, how wide is the matting if its area, so the area of the frame, equals the area of the picture? Okay, now the picture is 4 inches by 5 inches. You see that? So the area is 4 inches by 5 inches, which is 20 square inches. So that's the area of the picture. The area of the frame is also 20 square inches because it said they're equal. So the total area would be 40 square inches. So everything, including the frame, the mat, and the picture, is 40 square inches, okay? Now, this dimension right here, so we're talking, whoops, the outside of the frame, we know that from here to here is 4 inches. But this distance right here would be X, and this distance right here would be X. So this would be 2X plus 4. Do you see how I got that? Okay, now let's find this distance. From here to here is 5 inches. This is X and this is X, so this is 2X plus 5. So the dimensions of the whole thing, the outside, is 2X plus 4 times 2X plus 5. And that equals a total area of 40 square inches. So there's our formula. We're going to have 2X plus 4 times 2X plus 5 equals 40. Before we go on, any question about where I got all that from? Okay. I know you're thinking, couldn't we just take out a ruler and measure it? Yeah, I know. It's about critical thinking. So we've got 4x squared plus 10x plus 8x plus 20 equals 40. Combining like terms, 4x squared plus 18x plus 20 equals 40. Subtract 40 from both sides of the equation. 4x squared plus 18x minus 20 equals 0. Everything's even. We can divide by 2 and reduce it down. 2x squared plus 9x minus 10 equals 0. Okay, so let's take that equation, 2, 9, negative 10. 2x squared plus 9x minus 10 equals 0. Let's put it in a quadratic formula and find out what we get for x. A is 2. B is 9. C is negative 10. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 9 plus or minus the square root of 81 plus 80 minus 4 times 2 is negative 8 times negative 10 is positive 80 all over 4. x equals -9 plus or minus the square root of 161 all over 4. Let's see if 161 is a perfect square. I don't think so, but we'll find out. Nope, it's not. Okay, so we've got x equals -9 plus the square root of 161 all over 4. X equals -9 minus the square root of 161 over 4. Now, the original question, it said, how wide is the matting if its area equals the area of the picture? Round to the nearest hundredth of an inch. That was a clue right off the bat that the numbers weren't going to come out nice. So, parentheses, -9 plus, I'm doing this, this top one first, plus the square root of 161, close that up, close up the whole thing divided by 4. We get 0.92214, etc. Rounding to the nearest hundredth, we'd get 0.92, okay? Then doing the negative one, we get -5.422, so -5.42. But again, it's a distance, so the negative doesn't work. So our answer would be, x would be 0.92 inches. So the mat around the frame. So you're thinking, well, you know, we could just say it's about an inch. But anyway, to the nearest hundredth, it would be 92 hundredths of an inch. All righty. Any questions on that? Okay, so for tonight, section 10.2, part 2, wrap that up. Tomorrow we'll go on and look at section 10.4. Thursday, as you know, Veterans Day, and then we'll be back on Friday. So no class or office hour during Thursday. Anyway, have a great rest of the day. I'll be back at 1:15 should you need me. And with that, I'll stop the recording.